Slasher films. You all know the formula. For some reason, there's some beautiful woman in her underwear that's being chased by a maniac with a sharp object, right? And the first one, the great one, was terrifying. All of us, I think, still have that shower scene somewhere in our psyche. And this formula was so successful that what ended up happening is they did it again and again and again. And by the time you get to the six versions of this Scream film, you know the formula, right? Because at this point, they've become self-referential. It's terrifying. The slasher's coming. They're making jokes about the slasher coming. They're foreshadowing the slasher coming. You know what's going to happen, right? And still, you scream when it happens. And as you're thinking about this formula, you're screaming at the screen. Don't walk through that door. Look behind the couch. Don't answer the phone. Right? The formula is always the same. And your question is always the same, right? Even at the 6th version of the same movie. How could they possibly be so stupid? Why don't they just run away? Why do they go into the dark house? So here's a question for all of you. What if the answer is we really are that stupid? Right? What if you're looking at global warming and you begin to understand that we're not living with the consequences of it yet? That 90% of global warming has actually gone into the oceans. That we have misnamed this planet. This is not planet Earth, this is planet water. And what that means is most of the heat has gone into the oceans. In fact, about 337 zettajoules. For those of you who are not physicists, that's what that number looks like. So why is that number so important? Take a candle, light it, put your hand over it. You got to move it in less than a second because it gets hot. Blow out the candle, put your hand over it. No issue, right? Heat dissipates in the air. Now take a glass of water. Put the glass of water here, put a candle underneath. Stick your finger in it, no problem. 3 minutes, no problem. 5 minutes, no problem. After an hour, that water's boiling with one candle. Then it takes a long time before you can put your finger back in. And that's what we've actually done to the oceans. So here's the deal, you know what's coming. It's like a slasher film. It's out there. The heat is in the oceans. And the consequence of that is you're beginning to see 5 hurricanes in strings across the Pacific. You're beginning to see a tropical storm go to a category 5 in less than 24 hours when it hits Acapulco. You're beginning to see Asheville, North Carolina being wiped out inland from a hurricane. And it's not just hurricanes. See, what we've done is we've charged this battery with enormous amounts of energy, and that battery is water. And as that energy is released, you're seeing the same thing you see on your stovetop. So you cook up this beautiful stew for dinner, you cover it up before your kids come over, and then you take the top off and there's always this bothersome condensation, and the drops of water just come off. But guess what happens if you heat the oceans? You get the same thing happening in the atmosphere. When you put that much energy into water, you get a lot of condensation coming out. In fact, you get 11% more moisture in the atmosphere. And guess what's happened in the last 12 months when you put 11% more moisture in the atmosphere? You get floods in Saudi Arabia. You wipe out Valencia, Spain. You take out most of the Greek farmlands. You have unprecedented floods in the desert. You have snow in the desert. You have Mexico, New Zealand, Oman, UK, Uruguay, USA, having unprecedented amounts of water drop in short periods of time. Well, that's what happens when you heat something on your stove, and that's what happens when you heat a planet. You get more moisture. So as you're thinking about this stuff, I think scientists are being wildly understated because they are afraid to be wrong, and they have enormous pressure because NOAA can get canceled, because research programs can be shut down, because they're attacked every time they put something out over a sentence as opposed to the concept. And what we've actually done is we've put enough energy into the water that we may be heating this planet by 6 to 8 degrees centigrade. Not 1.5, not 2, not 3, 6 to 8 degrees centigrade. Now, a lot of scientists aren't saying this. There's a couple. There have been a couple of articles in the last year that are really important articles. But the point of this is we're going to overshoot this by a lot. And to put not too fine a point on it, this is going to be the coolest year you are going to see for the next 50 or 100 years. And it hasn't been a cool year. And so as you're thinking about this stuff, don't walk through that door. Don't answer the phone. You know what's coming. It's the law of physics. So do we just, jump out the window? Nope. I'm actually an optimistic curmudgeon on this stuff. And the reason why is because the cost of renewables is dropping so fast on a compound rate that it's going to make no sense to use coal, to use gas, to use oil, to use fossil fuels, not because we're going to stand there and protest, although that helps, but because it's going to make no economic sense, because this thing is compounding in solar at 20% per year. But we need a bridge. We need to bridge the next 20 to 30 years as we do get to net zero, and we will get to net zero. And that bridge is not a pretty bridge. It's not a bridge we want to use, but at this stage, it's a bridge we're going to have to use. Let me liken it to when you go to the beach. You go to the beach, beautiful beach, you lather on the coconut oil. It's 10 in the morning, it feels great. By 11, it's a little warm. By 12, it's hot. And by 1, you're looking for shade. And a beach is much more pleasant between 1 and 3 in the afternoon if you have a little shade. And that's exactly the same principle we have to apply to this planet. We need to create shade. We need to reduce the amount of photons hitting the Earth by 1 to 2%. And if we do that, we will be able to cross this bridge over the next 30 years. That doesn't mean give up on emissions. That doesn't mean don't reduce the emissions by 50% in the next 6 years, 100% by 2050. It just means that to be able to survive to 2050, we are going to also have to create a little bit of shade along with lowering emissions. 3 ways to do that. Space boys can stick stuff into space. Expensive, complicated, let them worry about it. Second option, do the same thing volcanoes do. Put enough dust in the atmosphere that you lower the temperature of the planet by 1 degree, which is what Mount Pinatubo did. But you shouldn't do that with volcanic ash. We need to test 1,000 chemicals in the stratosphere using high Earth balloons to figure out what is reflective, what is non-toxic to the stratosphere, what stays up there the longest. When it falls to Earth, what does the least damage? Third option, create low clouds. For those of you lucky enough to be in San Diego, you can see what the marine cloud layer does, or in San Francisco. These low-lying clouds, if you're under them, it's cold, it's damp, leads to what Mark Twain said once upon a time, the coldest winter I ever spent was a summer in San Francisco. That's the marine cloud layer. If we can create these marine cloud layer over glaciers, over ice, we will lower the temperature for that ice to be protected, for those oceans to lower the thing. We need a little shade. So let's not be stupid. We need the research on this stuff now. We need to be ready to deploy this in the next 2 or 3 years. It's not that much money. It's about $75 million to test the stratospheric stuff. But we need to do this right now, because otherwise, we're going to end up in a slasher film. And we're going to be the victims. And you know what's coming, so don't walk through that door. Thank you very much.